So today we're going to do 8.5, solving quadratic equations by factoring. Remember that to solve a quadratic equation means to find the x-intercept. This is the point where y is 0. And that can be 1 point or 2 points. But what if we don't want to graph it, or if our graphs table doesn't show us these points? Maybe they're fractions, maybe it's just not going to be easy to graph because the numbers are really spread out. There are other options. So one of those options is factoring to solve quadratics. So we talked about factoring before, and I told you guys to be sure that you remembered how to do this because we were going to use it again, and this is the day that we're going to use it again. So the first thing is we have to make sure that the quadratic equation equals 0. So for this one, that means that we're going to move the 21 to the other side. When you move to the other side of the equal sign, remember you have to change the sign. So we're going to have x squared plus 4x minus 21 equals 0. Now, when we factored this, they always looked like y equals x squared plus 4x plus minus 21. Or maybe they didn't even have the y part at all. We were just factoring the trinomial. Well, we are now graphing things y equals blah, blah, blah. Well, we are replacing that y with 0 because remember, this is the point where y is 0. So if we make y be 0, then we can find these x's for our solution. So we're going to factor first. Remember, we can factor using the x method. So we're going to have negative 21 on top, 4 on the bottom. And then we need to write down these factors. Since we have a negative c and a positive b, then our big number is going to be positive. So we're going to have negative 1, positive 21. That's only 20, so that's definitely not it. Negative 3 and positive 7 is the next one because 21 won't divide by 2. Well, negative 3 plus 7 is 4. So this is the pair that we were looking for. So when we factor this, we would get x minus 3 and x plus 7 equals 0. So this is kind of like factored form that we did right before the quiz when you had to rearrange it and get it back to standard form. Well, now we're rearranging and getting it back to factored form. But this time it equals 0 instead of y because we're going to solve it. So step 3 is set each factor equal to 0. So what that means is x minus 3 could equal 0. Actually, I don't need those parentheses. And x plus 7 could equal 0. And think about if you multiply something by 0, you get 0. So if either one of these is 0, then it is a true statement. Then we're going to solve each one of these little one-step equations. Sometimes they're one-step or sometimes they're two-step. But either way, this is a simple equation that we've been solving for a long time now. All right, so after you have solved that and gotten x by itself for both problems, then those are your solutions. And remember that you need to put the smaller number, in this case negative 7, first in your solution set. All right, so I'm just going to work through some of these. These first two are already set equal to 0. So I can go straight into my factoring. These are both positive, so that means both of our factors are going to be positive. 25 won't divide by 2, 3, or 4, so we're going to go straight to 5. And 25 divided by 5 is 5, and 5 plus 5 equals 10, so that is the pair that we want. So we have x plus 5 and x plus 5 equals 0. Well, since they're the same, and this is only true if they are exactly the same, plus and the number have to be exactly the same. So either x plus 5 and x plus 5 or x minus 5 and x minus 5, not one of each. Then you can just do it one time because they're both going to equal negative 5. Well, what that means is that you just have one solution. So if you graphed this, let me pull this up here real quick so we can see it. If you graphed this, then you would have a parabola that just touches the x-axis and then turns around. So, oh my, what did I just click? Oh, I should have done 3. So this is what that would look like. So it is on the x-axis at -5, and it does not go through it and come back. So it's just one solution. All right, on this next one, it is also already equal to 0. So we are going to do this one. Now remember, if there's not a number there, that's a 1. So that's -1 for your B. So since since both numbers are negative, then that means our biggest number has to be negative so that it makes the B negative. So we would have 1 and -21, 2 and -10, 3 doesn't work, and 4 and -5. And then when you add these together, you get -20, -8, and -1. So the one that we want is 4 and 5. So we have x plus 4 and x minus 5 equals 0. And then you just have to solve both of those. So x plus 4 equals 0. Subtract the 4. We get x equals -4. And x minus 5 equals 0. Add the 5. X equals 5. So this solution set is -4, 5. Now, you may have already noticed the pattern that whatever is in here, so like this one's a +4, we ended up with a -4. This one was -5, so we ended up with a +5. So it is the opposite, because think about -4 plus 4 is 0. 5 minus 5 is 0. So for the rest of these, I'm going to just kind of use that shortcut to solve my little one-step equations. Let's go to the next page. So before we can do the x method, I see I don't equal 0. So I'm going to have to subtract that 2 to move it to the other side. And so now I have -2 and 1 in my x. So that means that 2 only has one set of factor, 1 and 2. And so we need this to be -1, so that -1 times 2 is -2, and -1 plus 2 is +1. So we're going to have x minus 1 and x plus 2 equals 0. So that means for x minus 1 equals 0, x is +1, and for x plus 2 equals 0, x is -2. So that's our solution to that. The next one, same thing. We've got to move this x, or this 4x, over here in the middle. So this one, C was on the wrong side. This one, B, is on the wrong side. So we're going to have x squared minus 4x minus 45 equals 0. This was +4x, so when I move it, it has to be negative. And so then we're ready to do our x method. We've got -45 on the top, -4 on the bottom. So that means that the bigger number needs to be negative. So 4 and -45. 45 doesn't divide by 2. It does divide by 3. That gives us -15. Still not right, though. That's only going to give us -12 if we add that together. Doesn't divide by 4. Divides by 5. And we get -9. And 5 plus -9 is -4. So we are going to have x plus 5 and x minus 9 equals 0. So we have x plus 5 equals 0 and x minus 9 equals 0. Well, if x plus 5 equals 0, then x has to be -5. And if x minus 9 equals 0, then x has to be positive 9. So there's the answer for that one. Now, sometimes, like these next two, the b is missing altogether. If the b is missing altogether, remember, you need to use difference of squares. So you're going to do like, what is the square root of 4? It's 2. What is the square root of 81? It's 9. And so then you're going to have 2x plus 9 and 2x minus 9 equals 0, like that. So if you need to, go back to Unit 7 and rewatch the one on difference of squares. So we're just splitting these apart into their perfect square parts. Now this one is going to give us a two-step equation. That we have to solve, but we can do that. We've done that before. We're just going to subtract the 9. So we have 2x equals negative 9. Then you're going to divide both sides by 2. And luckily in algebra, we can just leave this, that fraction. That can be one of our answers. And then over here, we're going to add 9. So that's going to give us 2x equals 9 equals positive 9. And when we divide by 2, we're going to get positive 9 over 2. So that's our other answer. So our answer would be negative 9 over 2 and positive 9 over 2. And you don't have to do anything there. If you want to check and make sure it doesn't simplify further, you can, but you do not need to make it a decimal. You do not need to make it an improper fraction. Let's look at what this would look like, though, if we graphed it. So we would have 4x squared minus 81. So when we graph that, it goes way down to negative 81. That's on the y-axis. So I'm going to change this to be the y minimum to be negative 100, just so we can see that. And you can see this is what it would look like. And you can also see that it would cross through the x-axis at these decimal amounts. So it would be really hard to figure out what those x-intercepts are when graphing. So that's why we want another method to be able to do this. Also, it's on the y-axis, so its axis of symmetry is the y-axis. Anytime the b is missing, that is true. All right, on this one's a little bit easier. We just have to do the square root of 25, which is 5. And then we can go, oh, yeah, this is x plus 5. And x minus 5 equals 0. So we're going to have x plus 5 equals 0, x minus 5 equals 0. So for this first one, x would equal negative 5. And on the second one, x would equal positive 5. Because negative 5 plus 5 is 0, and 5 minus 5 is 0. So this would be your solution right there. And if we graph this one, it would look almost exactly like the one that's on the graph now, only it would be spread out to go through 5 and negative 5. It also wouldn't go down as far. Okay, so those are when the B is missing. Now we're going to do 2 for when C is missing. So notice when C is missing that they have a GCF because they both have an X. You can't do that up here because they do not both have an X. So if they both have an X like this and there's no C value that would require you to do the X method, then you can just factor out that GCF like always. So you can divide both of those numbers by 3. So I took the 3 out. They both have an X, so I took the X out. 3x squared, if we took out 3x, just leaves 1x. And 15x divided by 3x is going to leave us with 5. 15 divided by 3 is 5. This is still a factor, so you're still going to set it equal to 0. So you're going to have 3x equals 0 and x plus 5 equals 0. Well, if you divide this by 3, 0 divided by 3 is 0. And any time that you have a GCF factor like this, where C is missing, one of the answers is going to be 0. And then over here, it's just going to be -5, because -5 plus 5 would be 0. And so then your solution is -5, 0, like that. I'll graph this one real quick just so you can see what I'm talking about. 3x squared plus 15x and let's do this. Well, let's go down to about -20. See what that looks like. There you go. So you can see right here it goes through the origin. 0, 0 pops up on your calculator, and then right here, well, I can't get it to lock in on that. It goes through at 5. So you could have solved that one by graphing if you needed to, but sometimes you need to do it a different way. All right, and then this one, both of these numbers will divide by 2. They both have an x, so we're going to factor that out. And then 8x squared divided by 2x is just 4x. And -6x divided by 2x is -3. Again, this is in Unit 7 if you need to rewatch how to factor by GCF. So we're going to have 2x equals 0 and 4x minus 3 equals 0. Well, just like before, if we divide 0 by 2, we're going to get 0. And this one is a 2-step, so I'm going to add the 3, get 4x equals 3, divide by 4. So for this one, the other one, x equals 3/4. So our answers are 0 and 3/4. All right, so that's how to factor to solve a quadratic.